Hello everyone, hopefully you're having a good time at LATTE'21. My name is Pedro Filipe Silva and I'll be presenting the paper Building Beyond HLS Graph Analysis and Others. I'm from the Faculty of Engineering of the University of Porto in Portugal, and so are my co-authors, João Bispo and Nuno Paulino, who are also linked to the Inesctec Research Centre. I'd like to note I come from a pure CS background, while my co-authors have significantly more hardware experience. We hope you appreciated this viewpoint, especially as FPGAs move into CS domains. First of all, we'd like you to pick between these two perfectly reasonable options. One is, HLS is ready to break into the software development world, or two, HLS isn't really ready because there's too little abstraction. You still need too much knowledge of the underlying hardware. Just as an aside, these are Google Trends results for the search topics seen in the legend from the start of 2010 to the present. Obviously, take this with a grain of salt since comparisons between topics are vague, but the main takeaway is that the popularity of HLS remained somewhat steady until around 2015, hitting a period of steady growth until around 2017, which interestingly coincides with dips in the RTL-related topics, and then leveled out until around mid-2019 and is now experiencing a small drop. So back to our question, which one is it? Well, it turns out that if you really look around, opinions are very divided. There's not really a correct answer at this moment. We think the best approximation to the correct answer is that yes, HLS is ready, but you need really simple data flow programs or to be using good libraries or frameworks if a pure software engineer is going to do anything worthwhile. So just to be clear, this is a kind of FPGAs we mostly look at in our analysis, so FPGA acceleration cards. Obviously other FPGA products exist and we care about those as well, but most of what we'll say applies mainly to FPGA acceleration. These cards are now seeing increased usage in the high-performance computing community, which we'll mention later. So, as you'll see in the paper, this is a compilation of work on FPGA acceleration of graph analytic algorithms. We've chosen to look at graph analysis as a specific instance of an FPGA-unfriendly problem. Why is this an FPGA-unfriendly problem? Well, mainly because of frequent high memory bandwidth capacity and random access requirements, which don't really mesh well with current FPGAs. Anyways, looking at the table, the important thing to note is the distinction we make between HLS-RTL and HLS-RTL frameworks, which are tools that allow solving various problems instead of just one by a high-level paradigm, which is not necessarily a programming paradigm. So they're exactly the kinds of tools we're arguing for. We've come to some conclusions after analyzing these works. We go into further detail in the paper, but mostly we're able to tell that most works show some unhealthy patterns we'd like to see fixed. What's visible is that the majority of non-HLS literature focuses on solving a specific instance of the shortest path problem, which could very well indicate an RTL abstraction limit. Most HLS literature, on the other hand, and this includes frameworks, focuses too much on the hardware perspective. We think this is because of the FPGA-unfriendly nature of graph analysis. So what does this all point to? Well, it says that RTL can't fully tackle graph analytics, but HLS isn't quite there yet. We need high-level tooling. Again, further details in the paper, but here's a selection of issues raised in the HPC community regarding adoption of FPGA accelerators. Our main contribution here is to note that all of these issues could also benefit from higher-level tooling. So what are our conclusions? The time is right for redoubling research into FPGA acceleration, especially in new abstractions and toolsets. The way forward for FPGAs goes through HLS. This is a recurring sentiment in the literature. RTL may be hitting an abstraction wall. The HLS abstraction level isn't enough right now for unfriendly problems. Hardware knowledge remains a necessity in these instances. Also, RTL may become something like the assembly of FPGA programming. We argue that high-level tools are necessary for software developers to successfully use FPGA accelerators to their fullest. So we believe the future of FPGA acceleration will depend on investment into high-level tooling. These are the questions we have in the paper. We'd also like to showcase them here as well, so here goes. Are FPGA HLS accelerators currently competitive for graph analysis, or will they become competitive in the near future? If so, how? Are HLS libraries and toolsets for FPGA acceleration, especially in unfriendly applications, mature enough for use in production? If not, when will they be? How will increasing support for HBM affect the adoption of FPGAs as graph accelerators for unfriendly applications? What other promising technologies show potential to increase that adoption? And what impact will these technologies have on the potential of FPGAs as general-purpose hardware accelerators? So thank you so much. Hopefully you have a good time at the workshop. Here are the references for those of you who want to check them out.